for. Even I almost did it as well. So yes, keep an eye on that. So now question 19. Okay. Draw an electron dot structure for the cyanide ion. In aqueous solution, this ion interacts with H to form the acid. Should the acid formula written as HCN or CNH? Interesting. Okay, so for the cyanide ion, okay, we discussed this. It's C, and they also tell us there. So Lewis dot for Cn minus. Should it be HCN or CNH? Now, let's start with the Lewis dot. Okay, C. Carbon likes to have, well, not likes. Carbon has 4 valence electrons. Nitrogen has 5. Minus means they have 1 extra. So instead of it being 9, it'd be 10 total electrons. So carbon, nitrogen. Okay, we have 2, 4, 6. Oops, I think I already did it. Nope. Carbon. No, I definitely did overdo it. Okay, so let's try that again. Carbon, nitrogen. So Lewis dot. That's just first. They know they have a bond in there. Okay, and we need to now make up for still 10 of these. Okay, so if I did 2, 3, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that extra one somewhere. So with this, it would actually be better if we had. And the reason why I do it like this is because all these, as you can see here, each of them will bond with each other. And now we have actually, let me just make sure, because it should be 1 bond, and then okay, and then it's 1, 2, 3. Carbon likes to have 4. So, and nitrogen likes to have 1. Well, oops, because there's 2 bonds here. So 1, 2, 3, 4. So carbon's filled up for now. And 1, 2, 3, 4, 5. And there's an extra one. So just throw it on this side. So now, if we move 2 of these and 2 of these. Okay, now it makes more sense, which is what they did with the double bond. Okay, all right, and that makes more sense. And just to make sure, yep, this carbon had 1, 2, 3, 4, 5, 6. Well, actually, let me put on opposite ends. Okay, and now we're going to actually find out their number, their electron number. So let's see. Nitrogen prefers to have 5 electrons, so it has 5 minus 2 electrons from a lone pair, and then 6. 2 plus 6 over 2. So that equals 0. Perfect. And now carbon likes to have 4 minus 2 plus 6 over 2 as well, minus 1. So you notice that's where the negative comes from. So this would actually be our cyanide ion. Okay, so this is important, right? Because exactly when the hydrogen comes into bond, right, the hydrogen plus ion, the thing is that it wants, well, the HCN or CNH, we don't know yet, it wants to be able to make sure that it can resolve this -1 issue. So if we actually brought it into a closer picture, this right here is where the negative would be, and this would be neutral, as if you assign the numbers. It'd be 0, it'd be -1 here, and 0 here. So the hydrogen, which is a +1, okay, H plus, I'm going to draw a different color, would actually want to resolve the negative on that side. So you actually would have H bonded there to C, and then the triple bond and the N. This would actually be HCN. And yes, should it be HCN or CNH? It should be HCN. That is correct. And just to make sure we have the same amount of electrons just in the first part, 2, 4, 6, 8, 10. Exactly, so that one's correct. So with that being said, 1, 2, 3, 4. Okay, I see what I did there now. Okay, yep, the negative is hovering over the carbon, and exactly the Lewis structure. The H plus ion interacts with a negative charge on the C atom, which we know because of when we did the whole what the electron number was. Okay, so that is it for this question, and yep, it is HCN, so this is correct. So let's move on to now question 20.